All right, guys, today, once again, it is March 26, 2020, and this is going to be our math lesson for today. We're going to start with our anchor chart, our multiplication anchor chart. So let's start by sharing my screen. 1 second. Let me just make sure I'm on the right page before I show it to you. Okay. Yeah, so remember that if I do the gesture, you can do the gesture with me and repeat the word after me because it's just great practice. So I'm gonna put this in present mode so you can see it. So repeat after me. I say, you say, multiply, equal groups, number of groups, multiples, group size, factor times factor equals product, equation, commutative property, associative property. Efficiently, our sentence frame, I think the product is because array, rows, right? Horizontal, columns are vertical. Decompose, distributive property. And at the beginning of the year, we use our strategies such as repeated addition, skip counting, array model. And now again, remember, we're working towards even more efficient models and strategies. So decomposing and distributive property, we said, we're basically the same, except that distributive property is more of that, has that juicier word, right? It's juicier. And then area model. And so we're going to start off also with our learning intentions for today. All week, we've really been digging deep into area models and distributive property as an efficient model and strategy. And so our learning intention for today is I will deepen my understanding of the area model and how I can utilize it to solve one-digit number by two-digit number multiplication. My success criteria, I can use an area model and the distributive property to solve efficiently. And language intention, as always, we're trying to use our high mathematical vocabulary. So I want to hear you say, no, I can't hear you say it, but try to say it at home. Partial products, area model, distributive property. And our social intention for today, and always, I do the work even when no one is looking. So we're going to jump into reviewing our work from yesterday because the video was way too long and I didn't want to go into it even more. But I did ask you guys to solve these three equations using the area model and distributive property to solve. So I'm going to start with annotating and writing on here. So let me see if I can do my shapes like I did the other day. And if not, I'm just going to, I can draw a rectangle. 1 second. Okay, so we're going to start by multiplying 6 times 30. So I'm going to start with my area model. And I'm going to show you a few ways I can break this up. And let me use a different color. And of course, guys, it's kind of hard to do it on here, so please do not worry if yours is not perfect. Mine is definitely not perfect on here, but I'm trying my best. Okay, and then let me grab a marker to draw. Okay, so I could just multiply 6 times 30, which I will do in a moment, but I did want to show you that you can break it up even more because I know I can decompose that 30 into 3 10s, right? So 10, 10, 10. So that represents, these 3 10s represent the 30, and I can multiply it by 6 now. So I could do 6 times 30, which is another way, but let me start with this one. So now I know 6 times 10 is 60, and then 6 times 10 again is 60, and 6 times 10 again is 60. So now I have 60 plus 60, which is 120, and 120 plus 60 is 180. So 6 times 30 equals 180. But I want to use my distributive property, so I'm going to change it to another color. I know 6 times 30 really can be represented, like using the area model that I just used, right? 6 times 30 can be represented with my distributive property as 6 times 10 plus 6 times 10 plus 6 times 10. Okay, but now we know that 6 times 30 equals 180. And I just want to show you something again, right? If we know 6 times 3 is 18, and I have 6 times 30, I'm making 30 a multiple of 10, all I have to do now is, I'm going to do another color so you guys can see it, but all I'm doing, right, if I'm multiplying now, instead of 6 times 3, which gave me 18, I'm multiplying 30 times 6. I am just grabbing that 0 because 30 is a multiple of 10, and I'm adding that 0 down there, and it gives me the same answer. Now we're going to do 6 times 34. So let's break it off. Now we know what 6 times 30 is, so I am not going to do that. I'm going to decompose it differently now, especially now that I know what 6 times 30 is. So let me draw my area model. This is going to be, I'm going to decompose the 30 into a 30. And then I'm going to decompose this into 30 into a 30, the 34 into a 30 and a 4. And then let me draw, so now this, I'm going to have 6 over here as my height. And then I'm decomposing this into a 30 and into a 4. So now my equation is going to be, let me type it this time so it's a little bit easier. So now I'm going to write 6 times 34 is the same as 6 times 30 plus 6 times 4. And now I'm going to solve. So I'm going to grab another pen so I can show you guys how to solve. Let's do a different color again. So I already know 6 times 30 because I solved it earlier, gave me 180. And now 6 times 4, we should already know that fact, right? 6 times 4 is 24. And now I have, sorry, I didn't mean to do a plus sign right there. Hold on a second, guys. I mean an equal sign. I meant to do a plus sign. So now I have 180 plus 24. I have 0 ones and 4 ones, so that's 4 ones. Then I have an 80 and a 20 in the tens place. I know that gives me 100. I'm carrying over the 100 to the other hundreds place, which gives me 204. So that's 6 times 34 is the same as 204. All right, now we have one more. We have 6 times 54. So let me grab I'm going to represent this with an area model. So I'm thinking of how I'm going to decompose it. I think I'm going to decompose the 50 into a 50 and a 4 to make it easier for myself. And let me add another color so it's easy for me to see. Okay, so again, I'm going to write the dimensions of my area model. I'm going to label it so I don't get confused. I really don't want to get confused with my numbers. So this is, oops, I meant to draw. This is 6, and then this is going to be 50, and then this is going to be 4, because remember 6 times 54, I'm decomposing the 54 into a 50 and into a 4, which means I have 6 groups of 50. I can count that on my hand, and then I can show you my other strategy, but let me do that first. So 6 groups of 50. So 50, 100, 150, 200, 250, 300. So 6 times 50 is 300. And let me show you another strategy for that, right? So watch. I have, ooh, guys, this is kind of hard to do on here. Hold on a second. So I have, let's try it again. I just multiplied 50 times 6. But remember, 5 times 6 is 30, and then 50 is a multiple of 10. So I'm just bringing that 0 down. So it gives me 300. Okay, and now I have 6 times 4 again, which I already know what it is. I know 6 times 4 is 24. And so now I'm literally, all I'm doing right now is I'm adding my products together. I have 324. So my answer for this one, 6 times 54, is the same as 324. If you go back in your math notebook and you got those correct, give yourselves big check marks for each of these. These are more challenging equations that I'm asking you to solve, and you're using a new strategy. So kudos to you, which means good job, okay? So now I'm gonna clear everything. If you decided to redo this in your math notebook with me, you can pause it and do it again with me. You can rewind a little bit so you have it in your notebook so that you're understanding every step that we're doing together. If not, I'm about to clear it. So starting to clear all drawings, and I am going to go to the next page. So here's our number talk for today. What similarities do you notice between the first area model, 4 times 3, and the second area model, 4 times 30? So I'm gonna ask you to type in a second, and this is what I want you to type. Let me see if I can get my typing again. So a similarity between the first area model and the second area model is, okay? I'm gonna ask you to pause so that you can write down a similarity that you notice between the first area model and the second area model. Pause me now. All right, and we're back. You might have noticed, right, when you looked at the products for 4 times 3, it gave you 12, right? You might have noticed that. Let me grab a color. It gave you 12. And then when you see the second area model, 4 times 30, it gives you 120. Both of these products are similar. We have a huge similarity, right? We're multiplying 4 times 3 4 ones times 3 ones, or 4 groups of 3, and here we have 4 groups of 30. And the similarity is that the products are similar, except that for the second area model, instead of multiplying by 3, right, I'm multiplying, let me use a different color for this. I'm multiplying now by 30, and 30 is a multiple, sorry guys, 30 is a multiple of 10. And so instead of having 12, right, I'm taking that 0 and I'm adding it to my product, which gave me 120. And that is something that we want to work towards right now, is efficiently multiplying a 1-digit number by a multiple of 10. So just quickly as a practice, let me grab another color right now. Let me see if it lets me. It's been kind of weird. But I want you to try multiplying. If you know what, oops, that's too thick. If you know what 6 times 3 is, right? So write what 6 times 3 is. What would 60 times 3 be? Or both, do both. Or 3 times 60. I meant, just kidding, or 30 times 6. Okay, so if you write what 6 times 3 is, you can figure out what 60 times 3 is and 30 times 6. Pause me now so that you can try that. All right, you're back. You might have been like, well, Miss Maldonado, 6 times 3 is 18. And now if I have 60 times 3, 60 is a multiple of 10, so I'm just grabbing that 0 and I'm adding it at the end of my product, which gives me 180. You might have said, Miss Maldonado, the same thing, right? 30 times 6 and 60 times 3, right? If you look at it, 30 is a multiple of 10, 6 times 3 is 18, and I'm just grabbing that 0, right? And that gives me 180. Give yourselves a big check mark, little pat on the back if you're able to get that. So I'm gonna clear my drawings again so that we can do the last part of our lesson today, which is, one second, I'll exit out of my annotate. This is what you're going to be doing today, guys. This is your activity, getting to know the area model. You can't see the part of my title, getting to know the area model. You're gonna create a mini poster for 5 times 21 equals n. I know you don't have poster paper. I use my notebook because I don't have poster paper either, or not at home. So this is what you're gonna do. In your math notebook, you're gonna create a mini poster for 5 times 21 equals n. Your poster should have the equation up at the top. It should have an area model labeled, very similar to what I did earlier in the last slides. And if you need to pause so that you can kind of look at mine, go for it. A distributive property equation. So you should have this, 5 times 21 is the same as times plus times right? Because we're trying to understand partial products, how we can get partial products to get to the total product. And I definitely need an explanation from you, an explanation why the area model is an efficient model when multiplying a 1-digit number by a 2-digit number. And lastly, you can include a second strategy to support your answer. A lot of you feel very familiar with this way of decomposing, which is basically the same as distributive property. But if you want to do it this way as a second strategy, do it, okay? Make sure that you write a comment below on our YouTube video, or you can ask your parents to send a picture of your mini poster to my phone number, or to Mrs. Alonso's phone number, to Ms. Delgado's number. Again, I really want to highlight those who have been messaging me. Emily, Scarlett, I know Karina messaged me a week ago, Esteban, or who have been sending me things. Saori sent me a few things. I think Janet's commented. I think Catherine from Mrs. Alonso's class has commented. I want to see from more of you, or at least hear from more of you. I hope you guys are doing well. See you in our next math video.